Hey y'all. So today's objective is slope introduction. And this is an 8th grade standard, and it's an introduction, so I'm going to try to get you used to the vocabulary. So the first word is slope. Slope is a ratio of rise over run. So you got to make sure you get that down. Rise over run. I'll explain what that means. But rise over run. And slope is the steepness of a line. Steepness of a line. So if the line is really, really steep, or if the line is kind of flat. So that's the slope. It's the steepness of a line. Rise over run. So this is just a quick example. If you had a graph, and you see all these dots, and then I connected it, this slope is rather kind of flat. It's not a very steep slope. It's a little flat. And the rise, I don't know if you can see this. So rise tells you if you're going to go up or down. And run tells you if you're going to go left or right. So the slope is rise over run, and it's the steepness of a line. So we're going to talk about a few examples. Alright, so how to determine the slope from graphs and equations. So the first thing I need to teach you is how to figure out what the slope is looking at a graph or looking at an equation. And luckily the slope is very close to what we talked about before, unit rate. Not exactly unit rate, but very, very close to unit rate. So we're going to kind of talk about slope and unit rate. So in this first example, for a graph, you have to use rise over run, which we've already talked about. Rise over run. And here's a graph of something that costs money in pounds. Pounds of something that you go to the grocery store. And you see my points? So if I were to connect the points, I would have a graph, and my slope is my rise over run. My rise over run. So I need to count up first. So I start here, and I need to count up. 1, 2, 3. Get even with this dot. So do you see I counted up 3. And then my run is how far over I counted. So I counted over 1. So my slope is 3 over 1. And in this particular graph, it would mean $3 to 1 pound of something. So my slope is 3 over 1. I could also go from here to here, and I could count up 3, 1, 2, 3, and then over 1. 1, 2, 3, over 1. So the slope is always going to be the same. Up, and then over. Up, and then over. Or maybe down and over. But always rise over run. If you have an equation that looks like this, let's say you go somewhere and it's $4 per ticket. So the equation would be C equals 4T. C is the total cost. 4, and then tickets, per ticket. So the slope is this number right here, which we looked at before as the unit rate or the constant of proportionality. So the slope is 4 over 1. So that's $4 for 1 ticket. So the slope is 4 over 1 because you want to have rise over run. So that's an equation. So a graph you count, rise over run, and an equation you look at that number right there. That's the slope. Alright, so example 2, using slope to compare. So we're going to use the slope to compare some situations. Here are just a few things. Number 1, look at the steepness of a line. And then number 2, look at the value of the slope. So there are a couple of things we're going to look at. How steep the line is, or the value of the slope. So for store A, we can get $3.50 per pound of potatoes. So for 1 pound of potatoes, it's $3.50 for 1 pound. So that looks like a unit rate, which we've done, $3.50 for 1 pound of potatoes. Over here we have a graph that's store B. So here are the pounds right here, and here's the money. So if we have, this is 1 pound right here. And do you see? I went up and then over. Rise, over, run. I went up and then over. So I went up 4, over 1. So $4 for 1 pound. So what store are we going to go to? Are we going to get a pound for $3.50? Or are we going to get a pound for $4? Well, you would want to go to store A because a pound of potatoes is 50 cents cheaper at store A, and if you're going to get 4 or 5 pounds of potatoes, then you would want to get the cheaper price. So that is how you use slope to compare. Alright, so let's do a few more. Which store offers the better buy? What example is this? I forgot to write. Example 3. Which store offers the better buy? So we have store A. Selling, you can see I wasn't very creative. Selling pounds of something for money. And here are my dots. I'm going to connect them as best I can. And then over here at store B, it's $2.50 per pound. $2.50, so that's my slope. And over here, I have to go up. So I go up 2 over 1. So my slope is 2 up 2 over 1. Because remember, we rise and then we run. So this is $2 per pound, and this is $2.50 per pound. So do we want to go to store A or store B? What store would be better? Store A, because we can get $2 a pound, and over here it's $2.50 a pound. So this would be the better buy. Again, very similar to unit rate. The only difference is we're going to start calling it slope. Alright, so example 4, which train travels faster? Which train travels faster? So I have 2 graphs, train A and train B. Train A, I don't see any of my dots, but I put a dot up here. 8 miles in how many minutes? So we have to go up 8 miles. So these are miles. 1, 2, 3, 4, 5, 6, 7, 8. 8 miles in how many minutes? 1, 2, 3, 4, 5 minutes. So it's 8 miles in 5 minutes. That's my slope. Rise over run. 8 over 5. Alright, I don't want to confuse anybody. I went up 8 and I went over 5. So my slope is 8 over 5. Now on train B, I went up 5. 1, 2, 3, 4, 5. And I went over 1, 2, 3. 1, 2, 3. So I can go 5 miles in 3 minutes. 8 to 5 and 5 to 3. Now how do you compare 8 and 5 and 5 to 3? Let me write them up here. 8 to 5 and 5 to 3. There's a couple of different ways you could do this. You could get equivalent ratios by finding a common denominator, or you could divide. I'm going to show you both ways. If we wanted to find equivalent ratios, 5 and 3, what's a common denominator between 5 and 3? 15. So this would be 15. 24 out of 15. 5 times 3 is 15. 8 times 3. And this would be 3 times 5 is 15. So 5 times 5 is 25. So this one can go 24 miles in 15 minutes. And this can go 25 miles in 15 minutes. So which one is a faster train? Train B. But you could also divide using your calculator, and I forgot a calculator, hold on. So if I were to divide, I would do 8 divided by 5, and this is 1.6 miles in 1 minute, and this is 5 divided by 3, and this is 1.66 repeating miles in 1 minute. So which one goes farther? I could go 1.6 miles, or I could go 1.666 miles in 1 minute by finding the unit rate, and I still see that train B is faster. So notice I could get a common denominator, an equivalent ratio, or I could divide and find the unit rate. But the slope is 8 over 5 or 5 over 3. Alright, so example 5, who can run faster? So I made this up about Noah and Devin. So Noah can run, here's a graph, and Noah can run, let's see, right here, 2 miles in 10 minutes. And Devin can run 4 miles in 19 minutes. So my question to you is, who can run faster, and then how do you know? Who can run faster, and how do you know? Talk about the slope, the unit rate, give me some ratios, and be prepared to explain your answer tomorrow. Who can run faster, and how do you know? And I'll see you tomorrow.